Let's integrate sine cubed x cosine to the power of 4x dx. This question was requested by my best friend in the world, Herb, so I'm going to be doing it. And it's very similar to a question I've already done, so I'll be linking it to the side, I think, or something. I don't know. But anyways, let's get into it. So the first thing I noticed with this integral is that my sine is raised to an odd power, and my cosine is raised to an even power. So what this tells me is that I could factor one of those signs out so that I end up with sine x sine squared x times cosine to the power of 4x dx. Now the reason I've done this is so that I can substitute that sine x to rewrite it in terms of cosine using my Pythagorean identity, which is sine squared x plus cosine squared x gives me 1. Rewriting this in terms of cosine, sine squared x is equal to 1 minus cosine squared x. So now I could just plug that into my integral, so I get sine x times 1 minus cosine squared x times that cosine to the power of 4x, which I have not changed. And now what I could do is just apply u substitution because I have a function and its derivative in that integral. My function being cosine and its derivative being minus sine, but with some manipulation we could achieve that. So this is pretty straightforward now, so let me just apply that u substitution. So u is equal to cosine x, and my du is equal to negative sine x dx. And now rewriting this integral in terms of u gives me 1 minus u squared times u to the power of 4 du multiplied by a negative, because remember my du is negative. And now I could distribute this u in, that u to the power of 4, so that my integral looks like u to the power of 4 minus u to the power of 6 du. And now I could just apply the power rule, and I would get negative u to the power of 5 divided by 5 minus u to the power of 7 divided by 7, right? Because I'm just adding 1 to that power and dividing by that new power. And now, of course, plus c. And now I'm going to just substitute my u back in. And at the same time, I'm also going to distribute that negative so that I have u to the power of 7 over 7 minus u to the power of 5 over 5. Substituting that u back in, I get cosine to the power of 7x over 7 minus cosine to the power of 5x over 5. And because this is an indefinite integral, I need to add my arbitrary constant c. And that is my final answer.